You've experienced them, and I'm certain in your pre-calculus days you've dealt with them quite a bit. An example of an even function would be like f of x equals x squared. The idea is that f of negative x is the same as f of x. That's an even function. And then, I don't like red, it looks angry. Like when I'm grading papers. Haha. Odd function. You know, I've actually worked at schools where they wouldn't let you use red to grade papers. It wouldn't, because they, oh, that has a bad connotation. It puts people off. F of x equals x cubed is an example of an odd function. It happens to be odd with the power, but that happens to be the case here. But the idea is f of negative x is the negative of f of x. So like even f of x equals x is an odd function. So that, for example, if I said f of negative 2, that's going to be negative 2 cubed, which is negative 8, right? But it's the same thing as the negative of f of 2 cubed, f of 2, excuse me, which is the negative of 2 cubed, which is negative 8. So that's an odd function compared to the even function. So let's talk about how some shortcuts you can use for even and odd functions. So if you take the integral from, notice this says negative a to positive a, and it's not a to a, it's negative a to positive a, so it has to be symmetrical, like negative 2 to 2 or negative 10 to 10. So if it's symmetrical on an even function, you can reduce this down to 2 times the integral from 0 to a. And that could save you time, especially if it's a complicated thing and you don't have to worry about, if you plug a 0 in, that's probably all going to be 0 at that point. Not necessarily, because like cosine is an even function. So cosine of 0 is not 0. So what I mean by this is to say, if you were to do the x squared, here's your graph, as looking at this area under the curve and this area under the curve, you could just do it from one side and then multiply it by 2. That's what it's saying. And in the second case, f of negative x equals negative f of x is an odd function. So integrating an odd function from negative a to a is 0. And that's because the net change is 0. Because let's say you have something like this. It's going, here's your 2, here's your negative 2. You get area under the curve, area above the curve, and they cancel out because it's got that point symmetry. So that's an odd function versus the even function. Bless you. Any questions there? So again, the even function you can change to 2 times 0 to a. The odd function just can be 0. So let's look at a few examples of this. Here's, if you want to review this on your own, how to determine whether a function is even or odd. I kind of did a brief thing going through that, but I'm not going to spend more time on that. Okay, here we go. Negative 2 integral from negative 2 to 2 of 3x to the 8 minus 2. So it's an odd function, or odd or even function, first of all. If anything, I'd bet even because that x to the 8th, but let's find out. So let's plug in f of, we just say f of negative x. That's going to be 3 times negative x to the 8th power minus 2. So that's 3 and negative x to the 8th, the even power makes negative go away, so it's just x to the 8th minus 2, and that's the same thing as what f of x is. So this is an even function. Okay. So given that, this integral from negative 2 to 2 of the 3x to the 8th minus 2 dx is just the integral from 0 to 2 of 2 times the integral from 0 to 2 of 3x to the 8th minus 2. Okay. Still have to do the integration. It's not like it goes away. And what would this integral be? What's the antiderivative of 3x to the 8th?
3x to the 9th divided by 9 minus 2.
So 3x to the ninth over 9, that reduces to become x to the ninth over 3 minus 2x. And we evaluate this from 0 to 2. So we have 2 to the ninth over 3 minus 2 to the 2, minus 2 times 2, minus the quantity 2 to 0 to the ninth over 3 minus 2 times 0. That looks right now. Okay, so we have 2 times what? Obviously, the second part is just 0. Not a 6, that's just a 0. And we have 2 to the ninth is a big number. Is that like, I think it's like 512, isn't it? It's 512. So 512 over 3 minus 4. So that's going to be 2 times, here we get to play fun with fractions, 512 over 3 minus 12 over 3, because 4 is 12 over 3. So that's 2 times 500 over 3, or 1,000 divided by 3. That's it. Your sister's calling. Hey, sis.
Yeah, I don't know why I was.
Really?
It was weird. I was like, oh, shit, I gotta take his spam call.
The spam call, that uses your sister ringtone?
I don't know.
Do you have the ringtone for your sister?
Yeah, I might have accidentally put it on default or something.
Oh, okay.
Something I'll take care of later. It's a later problem.
I love the spam calls. You can never trust your phone anymore. So, yeah. Okay, evaluate the definite integral of the odd function. They tell us it's odd to begin with, of -5 sine x over the interval from negative pi to pi. Well, integral from negative pi to pi of -5 sine x dx, what's that going to be? Why is it 0? Because it's an odd function. And we go from -a to a, yeah, so that's a 0. I mean, we can go through and show why it's 0 if you want. But it is 0. And the integral is going to be, I mean, I'm just going to show it to you just to show it to you. The antiderivative of sine is negative cosine. So you have -5 times negative cosine of x. Evaluate that from negative pi to pi. So 5 cosine of pi minus 5 cosine of negative pi. Cosine of pi is -1, so it's 5 times -1 minus cosine of negative pi is -1 as well. So it's -5 plus 5, which is 0. I told you the day that my son had his accident, we got the call from the paramedic and I answered it and we were at lunch and my wife got angry until she found out what happened. But angry to answer the phone during lunchtime. And then the other day we were out and got a call. I'm like, I'm not going to leave these to go anymore. You never know what it really is. Okay. Let's try another problem then. We're ready to go on. Okay, a couple more here on this one. How would you do this one? Integral from -2 to 2 of x to the 4th. Would you think of that as an even or odd function or neither? Why do you think it's even?
Being honest, it's yes.
What's that?
I said, if I'm being honest, it's yes.
Well, that helps. F of -x is -x to the 4th, negative of x, sorry, -x to the 4th, but the negative goes away because it's the 4th power, so it's x to the 4th, which is our f of x. So it is even function. Okay, so we can change this into what? Now, you don't have to use it, but it's kind of a time saver. You could change it to 2 times integral from 0 to 2 of x to the 4th dx. So what would that be?
X to the fifth. 2 times x to the fifth divided by 5.
And evaluate that from 0 to 2. I'm going to call it 2/5. 2/5 times, and we have 2 to the 5th minus 2 to the 0. What's 2 to the 5th? Anyone 2 to the 5th? 32 is correct. 32 minus 0, so I get 64 over 5. Am I on the right page? And there's one more problem.
Isn't 2 0 1?
Oh, you are right. It is, no, it's, yes, it is. Yes, I was thinking you're correct. 2 to the 0 is 1. That was my mistake. So I should be looking at my notes. Minus 1, so it'll be 62 over 5. That's funny. I made this. No, gosh darn it. Dumb mistakes on my part. It is 0. It's 0 to the 5th there. My notes were right, but I didn't read them. But you're right. 2 to the 0 is 1. So it is 64/5. One last problem from this section. I don't think it printed out. I did do it. There it is. Okay, we have integral from negative pi over 4 to pi over 4 of 4 sine x. So think about what sine is, and I know we can easily integrate that probably in a matter of 10 seconds. Sine has a curve like this. And we're looking at pi over 4, negative pi over 4. So let's say negative pi over 4 is here, and pi over 4 is here. What I'm really after here, I'm not really too concerned about you getting these shapes or anything down, but just knowing what kind of function this is. Is sine an even or odd function, do you think? It'd be an odd function. Sine's odd. Cosine's even, sine's odd. So that this one, what's the answer? 0. That's it. I still worked it out for some reason. Okay, let's do one more thing and then we'll take a break and go over homework questions. List of things here. Yeah, let's talk about substitution.